Okay, this is the final stage in the filter press test. I have been running the cell, which was at 250 degrees Fahrenheit, under running water in the sink to cool it down. It normally takes 3, 4, 5 minutes to do that, so you can hold it by hand then, although it's a good idea to get some oven gloves or mittens or something like that so you can handle this when it's a little bit hotter. But basically, I've taken the cell out of the sink and put it in my trusty filter press cell body so that I have my inlet and outlet valve stem. The outlet side of the cell is down. I always want to relieve pressure on the inlet side of the cell. If I try to relieve pressure on the outlet side of the cell filter press, filter cake, and consequent filter seals the cell up, so I can't get rid of the pressure in the cell. So I always have to do it on the inlet side, and I'm going to attempt to do it without putting it back in the filter press. I may have to do that, but we'll see. And it's always a good idea, yeah, there we go. It's always a good idea to have some kind of a cloth or something over it, because you get, a lot of times you get the liquid come flying out, mud particles, and most mud labs you can see on the ceiling where they have released pressure on the cell. So I have released pressure. I am now going to hand tighten it back up because I'm going to invert it and to keep the mud on the tabletop. I will now release the stem. Not that I need to, it's just a habit that I've gotten into. And then I will remove the set screws, and I'll do them just like I did. I'll skip one, and I'm just kind of breaking the tension on it right now. I'll release these with a little more vigor in a minute. The idea is that these set screws are what is the only thing holding this cap in place. There's 6 of them, and the set screws need to be all the way in so that you don't get tension and have them welded inside the heating jacket. But at the same time, when you're releasing them, you want to watch that you don't get extrusion of the cell cap, because that means that you may have pressure trapped in the cell. But we heard and saw the pressure release from the cell, so we know in this particular case that's not although I am getting another milliliter or so of mud coming out that was inside of the valve stem. So it looks like I've got my set screws are all out. I'm going to take my valve stem completely off. Now, I mentioned earlier about the cell cap removal tool and what a handy device that is. Well, here it is here. And I'm going to screw this part of it in where the valve stem goes. And screw it in just enough for the threads to catch, and then the lever part put in one of the cell stop holes like thusly, and I just push down on it. Look at that. Very, very simple, and no hammering, no effort. The greased O-ring made all the difference in the world, and the cell cap removal tool made all the difference in the world. So that's a handy device that sell as a separate item. Every mud lab should have one. Now, I want to retrieve my filter cake, which is deposited on the filter paper, and I want to record that to the nearest 30/2 of an inch. Filter cake is typically described as by appearance and that appearance is rubbery, firm, thick, soft, all those scientific type terms. So that's what we're going to be looking at. I'll take a spatula and gently pull my filter medium out. Not much of a filter cake, very small and not uniformly placed. I'll lay it down on a napkin so you can see that better. And the thickness is about, looks like 3 milliliters. 3 millimeters of filter cake that's deposited. Now, to this, I want to gently rinse it off. And not much came off. And that is a true filter cake. It is pretty firm, rubbery, and that would be a desirable filter cake deposited on a wall with a hole, down hole. So that is the report I would turn in on a filter cake. 3 millimeters, firm and rubbery. As far as the filtrate collected, I collected a total of 11 milliliters of liquid during the test. 7 of that was what we call spurt loss that was collected at the 7.5 minute time. The balance was collected during the 30-minute period. So if I plug that into my formula for spurt loss, that is 2 times the 7.5 minute collected minus a combination of the 30 minus the 7.5 minute. And I make that out to be a spurt loss of 6. So I have a spurt loss of 6. I double that. That would be 12. No, wait a minute. 7 minus 4, that's 3 times 2. So I have a spurt loss of 6. Correction, I have a spurt loss of 6. And my total filtrate collected 11, since I'm using half the filtration area, half of the 7.1 square inches. I take that and I multiply my 11 milliliters times 2. And that is what I would report as my HTHP filtration test results. Would be 11 milliliters of filtrate collected. So at this point, I am done. The test is complete. From here, I will clean up. I will clean and dry the filter press jacket and cell thoroughly. I want to inspect the O-rings and make sure that they're all in good shape, that there's no dents, there's no flat spots on the O-rings. And had I gone above 300 degrees, which I didn't, but had I gone above 300 degrees, I would have replaced those O-rings, because as I mentioned earlier, they have to be replaced above 300 degrees Fahrenheit after each test. So basically, that's it. That's a complete HTHP filter press test run. I hope you can see that it's not particularly a dangerous test. It is a test that requires some common sense and some knowledge and patience of what you're doing. And if you take time to do things right, you can't get in trouble. You cannot get in trouble. So again, here is the filter cake measured, 3 milliliters with a total filtrate collected of 22 milliliters. This is the HTHP filter press, OFI part number 170-00 for the 115 volt, OFI part number 170-01 for the 230 volt. I thank you for listening.